Recall that an equation is a statement that sets two algebraic expressions equal in value. And solving an equation means finding that or those values of the unknown that will make the equation true. A quadratic equation is an equation in which the highest power of the unknown is 2. For example, 5x squared minus 7x plus 8 is equal to 0 is called a quadratic equation. Quadratic equation. Because as you see over here, the highest power of the unknown, which is x, is 2. You have 3 terms. This plus 8 is a constant term. It doesn't have any x in it. This one has got an x or x raised to the first power, and this one has got x raised to the second power. Similarly, x squared is equal to 9 is also a quadratic equation because the highest power of x is 2. Okay, there's only one term that has got an x in it. The other term is constant. But we could still say that only term has got an x squared in it. Therefore, this qualifies as a quadratic equation. So we could say the general form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a, b and c are constants and a cannot be equal to 0, because if a is equal to 0, you won't have a term in x squared. 0 times x squared will give you a 0 over here. So this will transform into a linear equation. Now before we go on to discuss the method of factoring to solve quadratic equations, I want you to understand how that method of factoring works. Let's say I have two unknowns, a and b. And all I'm going to tell you is, if you multiply a with b, you get 0. So a times b is 0. What can you conclude about the numerical values of a and b? Well, when two numbers multiply to give you 0, 3 things can happen. Either a is equal to 0 and b is not equal to 0, or a is not equal to 0 but b is equal to 0, or both a and b are equal to 0. In either of these cases, you will have a times b equal to 0. And that's actually the whole idea of using the method of factoring. You want to set up the equation as a product of factors on one side and 0 on the other side. And you want to say, okay, so if the product has to be equal to 0, at least one of these numbers is going to be a 0. Let's look at an example. Let's say we have the equation 2y times y plus 3 times 3y minus 1 is equal to 0. And we want to find out the value or values of y that will make the left hand side equal to the right hand side, which is 0. Or in other words, solve for y in this equation, or in other words, find the roots of the equation. They all mean the same thing. Finding the roots means solving for the unknown. Root or roots because there can be one or more values of y that will make this whole thing equal to 0. Now if you look at this side, this is a product of 2 and y plus 3 and 3y minus 1. So there are 4 factors on the left hand side of this equation. Now for the product to be equal to 0, at least one of these is equal to 0, right? Now 2 is not equal to 0, of course 2 is a constant, so let's forget that. Now either y is equal to 0 or y plus 3 is equal to 0, which obviously means y is equal to -3. Or 3y minus 1 this factor could also be a 0, which means 3y is equal to 1 or y is equal to 1/3. All of them cannot be 0 at the same time because y cannot be 0 and -3 and 1/3 at the same time, right? So one of these, of course, is 0. The others aren't. So we would say the roots of this equation are y is equal to 0 or y is equal to -3 or y is equal to 1/3. You may want to note that this isn't a quadratic equation because when you multiply y with y, you get a y square, right? And when you multiply the y square with another y, that gives you y raised to the third or y cubed. And that's exactly why you are having 3 roots. An equation in which the highest power is 3 will have 3 roots. They may or may not be different. Similarly, a quadratic equation in which the highest power of the unknown is 2 will have 2 roots or 2 solutions. The 2 solutions may be equal, may be the same number, or they may be different. Now let's look at a few quadratic equations and see how we could use this technique to solve them. Let's say we want to solve 2p minus 1 times p plus 1 is equal to 0. So the product of these two factors, 2p minus 1 and p plus 1, is equal to 0, which means either 2p minus 1 is 0. Which means if you solve for p from here, you add 1 to both sides, you have 2p is equal to 1, which means p is equal to 1/2. Or, so either p is equal to 1/2 or p plus 1 is equal to 0. That will also make this product 0, right? Which means p is equal to -1. So either p is equal to 1/2 or p is equal to -1. These are the 2 roots. And by the way, if you want to check that this indeed is a quadratic equation, you can multiply these out. 2p times p will give you 2p square, and that's the highest power of p in this equation. How about 2x plus 1 whole square, which means 2x plus 1 times 2x plus 1 is equal to 0. Now there are 2 factors in this equation. One is 2x plus 1 and the other one is also 2x plus 1. That's why we have a square here, right? So we would say 2x plus 1 has to be equal to 0. There's no either or, right? Or 2x is equal to -1 or x is equal to -1/2. Remember, I had said the 2 roots may be the same or different. In this equation, the 2 roots are the same, and that's equal to -1/2. How do you solve, let's say, a squared plus 2a is equal to 0? Now, if you want to use the method of factoring, you want to set it up as something times something is equal to 0, and set those 2 factors each equal to 0, right? So to be able to do that, you need to factorize this expression. Take a out, that's a common factor. So we have a times a plus 2 is equal to 0. If you take a out from a square, you're left with a. If you take a out from 2a, you're left with a 2. So we could say either a is equal to 0, that's one of the factors, or a plus 2 is equal to 0, which obviously means a is equal to -2. So the 2 roots are 0 and -2. How do you solve x squared plus 4x minus 21 is equal to 0? The idea here is to split up the term in x into 2 parts so that they obviously add up to 4x. You can change the problem, right? If it's a plus 4x, they have to add up to plus 4x. So you need to find 2 numbers that add up to give you positive 4 and that multiply to give you the product of the coefficient of the term in x squared. Now what's the coefficient of the term in x squared? If you see a x square, you could well think of it as a 1x square, because x square is the same as 1 times x square. So split this up into two parts that add up to this and that multiply to give you 1 times the constant term, which is negative 21. So basically we are looking for two numbers. Something plus something is equal to positive 4. And something times something, those same two numbers, is equal to 1 times negative 21, which is negative 21. Now because the product is negative, one has to be a positive and the other one has to be a negative. That's the only way you could have a negative product. And then because the sum is positive, that means the positive number is more than the negative number. So you could use these clues and think about 7 times 3 is 21. So it would be a plus 7 and a negative 3. And indeed, if you multiply these two numbers, positive 7 and negative 3, you get negative 21. So we can rewrite the equation as 1x squared. We don't need the 1, right? 1 times x squared is x squared, like I already said. X squared plus 7x minus 3x. They add up to give you 4x. So we are not changing the problem. Minus 21 is equal to 0. So we just rewrite the problem in another way, just to have 4 terms in it instead of 3 terms. And now we are going to pair them up and factorize. Factorize x squared plus 7x. The common factor is x. Take it out. Parentheses. X plus 7. Do the same thing with these two. The common factor is negative 3. Take it out. Left with the x on this one. And negative 3 times positive 7 gives you negative 21. Now if you look at these two, x plus 7 is a common factor. So let's take that out as a whole. So we have x plus 7, the common factor out. We are left with an x and a negative 3. There you go. You have something times something is equal to 0, and this is exactly what we were looking for. This was the whole idea of splitting this up so that we could pair them up. So now we could say either x is equal to negative 7 because x plus 7 is equal to 0. That can only happen when x is negative 7. Or x is equal to, you got it right, 3, because 3 minus 3 will give you 0. So these are the two roots of this equation. How about this? T squared minus 8t plus 12 is equal to 0. So we rewrite that as t squared and then split up the minus 8t into two parts, something t plus or minus something t, and then in the end we have a plus 12. So again we are looking for two numbers that add up to negative 8. And the multiply to give you 1 times positive 12. So something times something is positive 12 or 12. Now the sum is negative. If you have both positives, the sum will never be negative. And the product is positive means either both numbers are positive, which is impossible. Therefore, both numbers have to be negative. Now how about negative 3 times negative 4? Negative 3 times negative 4 is positive 12. But the problem is negative 3 plus negative 4 will not give you negative 8. It will give you negative 7. So these numbers don't work. So our next guess is negative 6 times negative 2. Negative 6 times negative 2 is positive 12, okay? And how about negative 6 plus negative 2? Yes, that's indeed negative 8. So we got them. So we are going to split up negative 8t as negative 6t minus 2t plus 12. That's equal to 0. And then go on to factorize these two like we did in the previous one. Take the t out, t minus 6, minus 2 out, t minus 6 again, because negative 2 times negative 6 will give you positive 12, is equal to 0. T minus 6 is a common factor between these two terms. Take it out, as a whole in one single parenthesis, and you're left with a t from the first term and a negative 2 from the second term. There you go. So now we could say either or. Either t is equal to 6 or t is equal to 2. These are our two roots for this equation. What if the coefficient of the highest power of the unknown is not 1? There's a 1 here, right? What if you don't have a 1 over here? What do? Let's have a look. Let's say we have 3x squared minus 5x is equal to 12. Now we don't have a 0 on the other side, so all you need to do is get this 12 on the other side by subtracting 12 from both sides. So we can rewrite the equation as 3x squared minus 5x minus 12 is equal to 0. Always try and get a quadratic equation in this form. Ax squared plus bx plus c on one side and 0 on the other side. Okay. Now, again, we are going to split up this term, obviously. What's the criteria? Something plus something is equal to negative 5. And then, those two numbers multiply to give you 3 times negative 12. The coefficient of the highest power, the x squared term, the coefficient is 3, times the constant term is negative 12, which is negative 36. One has to be a negative and the other one has to be a positive. There's no question about it. And because the sum is negative 5, the negative number is more than the positive number. That helps us nail down our numbers, and they would be negative 9 and positive 4. Negative 9 times positive 4 is negative 36. Negative 9 plus positive 4 is negative 5. So there we go. 3x squared minus 9x plus 4x, which obviously is equal to negative 5x, minus 12 is equal to 0. We have a common factor as 3x between these two. Take a 3x out. Left with a x because there's a x squared. Minus 3. 3 times 3x is 9x. Plus, common factor between these two is 4. Times x minus 3. Positive 4 times negative 3 is negative 12. Is equal to 0, of course, on the other side. And then, x minus 3 becomes the common factor between these two terms. Let's take it out. X minus 3 times 3x plus 4 is equal to 0. We have come to the either or step. Either x minus 3 is equal to 0 or x is equal to 3. Or 3x plus 4 is equal to 0, which means 3x is equal to negative 4, taking the 4 on the other side, which in turn means x is equal to negative 4/3. So we have x is equal to negative 4/3 or x is equal to 3. You could also go the other way, that is, given the roots of a quadratic equation, find the equation. Let's say a quadratic equation has got roots x is equal to 1 and x is equal to negative 3. We need to find the equation. Now x is equal to 1 means what? If you do x minus 1, you're going to get a 0. Therefore, x minus 1 is a factor of the equation. In the same way, x is equal to negative 3 means if you do x plus 3, you're going to get a 0. Therefore, x minus 1 times x plus 3 is equal to 0 is the equation, whose roots are x is equal to 1. If you plug in 1 over here, you get 1 minus 1. So this factor becomes 0. If you plug in negative 3 over here, you have this factor as 0. So let's open this up using the method of FOIL. First, x times x is x squared. Outer, x times positive 3 is plus 3x. Inner, negative 1 times x is negative x. And last, negative 1 times positive 3 is negative 3 is equal to 0. Combine the like terms. You have x squared plus 3x minus x is plus 2x minus 3 is equal to 0. This is the equation whose roots are x is equal to 1 and x is equal to negative 3. Let's try another one. This time I'm going to say, let's say y is equal to 1/2 and y is equal to negative 3 are the two roots of a quadratic equation. We need to find the equation. Going by the same logic, the two factors would be y minus 1/2 and y plus 3. They would multiply to give you a 0. Let's open them up. Y times y is y squared. Y times positive 3 is plus 3y. Y times negative 1/2 is negative 1/2 y. And negative 1/2 times positive 3 is negative 3/2 is equal to 0. Now we have a couple of fractions here. They both have a denominator of 2. In order to get rid of the fractions, let's multiply both sides of the equation with 2. Now on the right we have 0 times 2. Now what's 0 times 2? It's obviously 0. So there's no change on the right hand side. On the left hand side, we have 2 times y squared, that's 2y squared, plus 2 times 3y, that's 6y, plus 6y. 2 times negative 1/2 y is negative 1y, or simply negative y. And 2 times negative 3/2 is negative 3. Combine the like terms. 2y squared plus 6y minus y is plus 5y minus 3 is equal to 0. This is the equation whose roots are 1/2 and negative 3. So that's all about solving quadratic equations by the method of factoring. I'll see you soon.